Let's see how we do. So this is factoring review. And you guys, with integrated math, factoring is not something that is really emphasized. They just assume you know how to do it. It's a real flaw with the book we use. So the other teachers in the school and myself are inputting this kind of within and between lessons. That's why we're doing this. So if you feel like you're missing something or like I've never seen that before, or I don't know how to do that, it's not your fault. It's the whole system has some flaws in it still being worked out. This is one of them. Okay. So the greatest common factor is the factor that can be divided out of each term. So before we had this. Remember I gave you this problem or something like it? You guys all know how to distribute that. Distribute this 2 times x, 2x, 2 times 1, 2. Okay. This is the process that you already know. You already know how to distribute, right? What we're going to learn here is factoring. We're going to factor. Distributing is multiplication, factoring is division. And you're going to see that you can go in a big circle to check yourself and know 100% if you got it right. So essentially what we're going to be able to do is we're going to be able to see that, well, instead of multiplying in, I'm going to factor and divide out whatever's in common, the greatest amount that is in common. I have 2x and I have 2, so we're going to learn today how we factor out a 2, and we have this left over. Now, if you did this right, then, this was distributing to get here, then I factored out. You should get back to where you started. Every single time you can see if you got it exactly right by getting back to where you started. So we're going to leave this here. And now we'll start with an easier example. We'll start with 2 numbers. So if I have these 2 numbers like this, let's go 12 and let's go 32. Just 2 numbers in space here. Here's the process that's going to help us. What does 12 break up into? 12 breaks into what?
4 and 3.
4. So you're going to write it below it. 4 and 3. Do any of those numbers break up further? 4 breaks into?
2.
Watch. 2, 2. You see? Just making a line of all the factors. Can any of these break up further? No. When you're done, put a 1. Okay. Over here, 32. What does 32 break into?
16.
Okay. 16 and 2. What does 16 break into?
8
and 2. What does 8 break into?
4 and 2.
What does 4 break into?
2 and 2.
2 times 2 times 2 times 2 times 2 gets us 32. Are we done? We done?
Yeah.
If you're done, put a 1. If you're done, put a 1. What is in common between these 2? Let's see. We got a 2. We got a 2. Once you have what's in common, you multiply them together, and that is your greatest common factor. That would be the value that I'd be able to divide out of each of those. So if I said my greatest common factor was 5, that wouldn't make sense because can I divide 5 from 12? No, not with an even number. We're looking for even numbers though. Otherwise life gets way too complicated. Let's keep it easy. Could I divide 5 out of 32? All right. So we know 4 is our best bet with this. Let's try one more, and then I'll show how this applies. So just wait for it if you're still like, well. All right, how about this? Let's go 18, and we'll go negative 28. There's a negative in there, but then just when you're done, you don't end with the 1, you end with a negative 1. All right, so let's see this work on here.
Let's go. Easy.
All right, 8, put your phone in your pocket.
Negative 20.
On your pocket, please. It is very similar to the factoring tree, but instead of having to do the factor tree on the side and then put the lines, the numbers in that straight line, you kind of just go in here and you put, okay, 18 is 9 times 2. Then you look to see, well, could I break it up further? So it would look like this if it was a factor tree. It'd be 9 and 2, and then you'd say 3 and 3. Right? So it's the same thing. You're right. If you are better off doing the factor tree and then put it in the line, you could do that. Okay. What was in common between these two? Anything else? So the greatest common that we could take out is a 2. Okay. All right. Now, before we get going on tic-tac-toe, we're going to go one step up. Yeah?
Aren't you supposed to multiply those?
Got it. If I had more than one thing in common, if there was a 3 in common too, as well, then I'd multiply 3 times 2 and I'd have 6 out here. But because this is just what's in common, it's what we're dividing out of each of them.
Okay.
Okay? And I think the next step will affirm this. So that's a good segue. Thanks for bringing that up. It was good. All right. You want to try something slightly harder? How about this? Let's make our line. What's 2x? 2 times x? What's 4? 2 and 2. Now, I want you below these columns. This is an important step. I want you to put some parentheses down there for that the next row. Okay. Now, what's in common is a 2, so that's going to go outside. What's left over in the column is what's left over down here. We multiply, everything is multiplying or dividing. So we're not adding. What's left over in this column? Oh, I guess I added 1. X. What's left over in this column? Positive 2. Done. And then you look and you say, well, I want to know 100%. I was told that I get 100% on this if I double check. So then you distribute it back. And did you get where you started? Yes, you did. So you know that that is the correct factor. You guys see a couple of these. But it really is just like a process. It's a process. So let's look at one that's a little trickier. Let's do, all right. Make your lines. Break it all down. Remember, x squared is just x times x. Why are there 2 dogs on campus?
Why not?
Yeah, that ain't right. Stay right here.
Good job. See you. What's your name? They were cute. Yeah, exactly. They were cute.
These are big dogs.
Okay.
German Shepherd. 2.
I got him out. What were we doing in here? This.
Stop recording.
Oh, yeah. Still recording. There's some dogs on campus. I let them out and close the door. All right.
What doggos?
Doggos. 2x squared is 2.
2.
X. 8x. Let's see. 4 and 2, if you couldn't see it. 4 is 2 and 2. X.
1.
What's in common?
2.
There's a 2 in common. What else is in common, though?
X.
Watch. Parentheses. What's going to go on the outside? Yeah? 2x goes on the outside. What's left over in this column? X. X times 1 is x. What's left over in this column? 2 times 2? Done? Yes. Good. Now, the reason I leave the 1s is because when we get rid of everything, right, except the 1, we are still reminded that a 1 is in that place. You could pull that out if you wanted to. But if you leave it there, then you won't mistake, you won't have the wrong idea that everything was out and there's nothing left. Okay. It's kind of like if you do, let's see. If you have 2 over 2 times x, and you reduce this, 2 over 2 is 1. I don't want it to be confusing where, like you might think, well, there's nothing left on top. So the reason I'm including the 1 is, this is really 2 times 1. So when we cancel those 2's, because 2 divided by 2 is 1, then we have to see that there's something left over on top. And that's kind of a helpful hint for that. Now, if you see it the other way, that's fine. This is just the way that the tool I'm using. Okay. You guys, do you want to do one more? Are you ready to play the tic-tac-toe game? Tic-tac-toe. Okay. All right, go ahead and get out a piece of paper. Thanks for watching. Goodbye.